2 of chapter 6, we're going to talk about the unit circle. When we talk about the unit circle, we talk about one unit circle, so we're going to let r equal 1. So this distance right here, this point right here is 1, 0. This point up here is 0, 1. This point is -1, 0, and this is 0, -1. So those are all those points. So this would be at 90 degrees or pi halves. This would be at pi or at 180. This would be 3 pi halves. 3 pi halves are 270, and this would be back at 2 pi or 360. Okay, so as we talk about the unit circle, we're talking about where a radius equals 1. So if we look at our what we call the circular functions, that's when we go ahead and look at sine of an angle, cosine of an angle, tangent of an angle, and we look at it in terms of, normally talk about sine as y over r, and cosine is x over r, and tangent is y over x. Well, here when we're talking about the unit circle and talking about circular functions, here is where x or r is equal to 1. So the big thing is r equal to 1. So this means this is just y, this is just x, but tangent is still y over x. So this is just y and this is just x. And then the reciprocals, cosecant of an angle is just 1 over y. And then secant, the reciprocal of cosine, is 1 over x. And then cotangent would be x over y. And so those are called the circular functions. And then from these circular functions, we can go ahead and build what we call the unit circle. And you'll see this, and this is part of finding the exact values of sine, cosine, and tangent of various angles. So the unit circle is a circle like this. And so then we're looking at the angles. So we're looking at the angles here. So we're looking at 30 degrees, we're looking at 45 degrees, we're looking at 60 degrees, 90 degrees, of course, 120, 135, 150, back to 180, 210, 225, 240, 270, 300, 315, 330, and back to 360. And so then you're just basically going to fill this out. 0, 0 degrees, 30 degrees, 45 degrees, 60, 90, 120, 135, 150, 180. And then you're going to do the radians as well. So after you're done doing this, you're going to go ahead and do the radians as well. So this would be 3 pi halves, 300, and then 315, 330, and then the radians would be, this would be 2 pi, this would be pi sixth, this would be pi fourths, this would be 2 pi sixths, which is pi thirds, this would be pi halves, because really these are just counting, this is 30, this is another 30, this is another 30, right? So 3 pi sixths is the same as pi halves, and so you can just count by thirds or by sixth, and then just reduce your fractions. So this is 2 pi thirds. This is 3 pi fourths. So I'm counting by fourths. 1/4, 2/4, 3/4, 4/4, which is just pi. And so you fill this out doing that. So this is 5 pi sixth, 7 pi sixth, 8 pi sixth, 9 pi sixth. Or sorry, this is 6 pi sixth. This would be 7 pi sixth. This would be 8 pi sixth, which is same as if I reduce that by 2, I get 4 pi thirds. 3 pi halves, which is just times that by 3, that would be 9 pi sixth. This is 10 pi sixth. This would be 11 pi sixth. Let me do that right. 11 pi sixth. And this would be 12 pi sixths, which is 2 pi. And this would be 4 pi fourths, 5 pi fourths, 6 pi fourths right here, 7 pi fourths, 8 pi fourths here. So you fill that out, and then you fill out what the sine, cosine, what the circular functions are. So you fill out what sine is. Sine is my y value, so that is 0, and cosine is my x, so 1. This one, sine is 1/2, where x is root 3 over 2 because my r in this unit circle is 1. So my x's represent cosine where my y's represent sine. And you would go around and you would fill out this whole entire thing with those points of every single one of these points, what the coordinate is, the x and y coordinates of every single one of these points out here on the unit circle. So that is the unit circle. And then here's the domain of those functions on the unit circle. So my domain means my x's, my choices for, not my x's, I'll say that wrong, my thetas, so my choices for thetas, my angles, are anywhere from negative infinity to infinity. I can choose any angle I want to, and I can get an answer. For tangent and secant, well, there I'm a little bit limited because tangent is y over x, and secant is 1 over x. So I cannot have x in the denominator, right? So that means I can't have wherever x is 0. So that'd be at pi halves and at 3 pi halves, so anything with a pi halves, every odd with a pi halves basically. And then cotangent is x over y, and cosecant is 1 over y. So over y is 0, so that's at 0, at pi, at 2 pi, at 3 pi, 4 pi. So that's every n pi. N just stands for any integer. So those are the domains of my circular functions. And so if you want to, you could use these are your choices of thetas, but your y values, your answers, you know, the answers to these, those are what you're going to find in here. And so how you can find these numbers right here, you can do that hand method. You can do the hand method, root something over 2, or you can do the two triangles. You can do a 45 45 90 triangle, which is 1 1 root 2, or you can do a 30 60 90. This is 30, this is 60, this would be root 3, this would be 1, and this would be 2. So you can use that to figure out what all these are. But so that's how you figure out the unit circle.